Welcome to Math Vision tutorial. Today we shall be talking about mean value theorem, that is the MVT. We shall look at what mean value theorem is all about. We shall see what mean value theorem is talking about. Mean value theorem is talking about the slope of a secant line and the slope of a tangent line. That is the slope or gradient of a secant line and the slope or gradient of a tangent line. Mean value theorem is talking about the equality of the gradient of a secant line and the gradient of a tangent line. What is a secant line? A secant line is simply a line which is joining two points on a curve, while a tangent line is a line which touches a point on a curve. We shall see more of it by the time we proceed in this class. So let's look at the definition of mean value theorem. Now, let f be continuous on a closed interval AB. Don't forget, this is a closed interval. It is including A and B. Let f be continuous on a closed interval AB and differentiable in the open interval AB. This is an open interval, and this kind of interval is not including A and B. So mean value theorem is saying let f be continuous on a closed interval AB and differentiable in the open interval AB. Full stop. Then there exists at least a point C in between A and B such that f of b minus f of a over b minus a equals to f prime of c. Let's look at the definition once again before we proceed. Mean value theorem is saying that a function, the gradient of a secant line is equal to the gradient of a tangent line if two conditions happen. Now, let f be continuous in a closed interval AB and differentiable in the open interval AB. Then there exists at least a point C in AB such that f of b minus f of a over b minus a equals to f prime of c. Now, let's consider the figure below. From the figure below, we have the curve of a function which is f of x. And on this curve, we have the interval AB. We are considering the interval AB on the x-axis. So at the point x equals to a, we are going to have f of a because this is the function. If x equals to a, then on the y-axis we are going to have f of a because we are going to evaluate f of a to know the value at the y-axis. Also, if x equals to b, then y will be equal to f of b. So on the y-axis, we are going to have f of b. That is why when s equals to a, then f of a, then y equals to f of a. And the point at which they join, at which they intersect is a comma f of a. Likewise, when s equals to b, we have that y equals to f of b, and the point of intersection is the point b comma f of b. Now we draw a line joining these 2 points, and the line joining these 2 points is what we call the secant line. This is a secant line because it is a line joining the 2 points. So if you should look at this curve, you will see that this is a continuous function because in the interval AB, we have that the function is defined throughout the interval AB because from A to B, there is no break in the curve. The curve is continuous. There is no break, there is no hole in the curve from A to B. The curve is continuous in the interval A to B. So that means the curve is continuous. And also, this curve is differentiable in the open interval AB. So now, since this curve is continuous and differentiable, mean value theorem is telling us that there exists a point C. There exists a point C in AB such that this happens. So there, if the function is continuous in this closed interval AB, then there exists a point C in between AB, such that by the time we find the gradient function of this curve, remember that we said that the gradient function of a curve is the gradient of the tangent to that point on the curve. So the gradient of this function at the point C, the gradient of the function at the point C is the gradient of this secant line to the point. So mean value theorem is telling us that the gradient function of this curve at point C is equal to the gradient of this secant line. So now, the gradient of a straight line joined by 2 points is given by y2 minus y1 over x2 minus 1. Don't forget this. The gradient of a straight line joined by 2 points. This is a straight line. This secant line is a straight line joined by 2 points. So the gradient of a straight line joined by 2 points, as we have learnt in our high school, is y2 minus y1 over x2 minus x1. So the gradient of the above straight line, which is this straight line, is simply, don't forget that this is our x1, this is y1, also this is x2, and this is y2. So from the formula of the gradient joining of a straight line joining 2 points, we have that, so the gradient of the above straight line is simply f of b, because this is y2 and our y2 is f of b minus our y1 is f of a, f of b minus f of a over what is our x2, our x2 is b, which is b, minus what is our x1 is a, which is a. So the gradient of the above straight line in this case now is f of b minus f of a over b minus a. So let's take note of this. So now we proceed. We say, remember that finding the gradient of a curve is by differentiating the function of the curve. We remember that as we have learned in the last video. Remember that finding the gradient of a curve is by differentiating the function of the curve. So that is the gradient of f of x, which is this curve. The gradient of the curve at every point is f prime of x or the y dx. Hope we haven't forgotten this. So now we have that where f of x is called the gradient function of f of x. We learned that f prime of x, where f prime of x is called the gradient function of f of x, because we learned in the last video that our f prime of x is called the gradient function of f of x. F prime of x is the slope or gradient of the tangent to the curve at any point on the curve. At any point on the curve. F prime of x is the slope or gradient of the tangent to the curve at any point on the curve. Hence, the gradient or slope of f of x at point s equals to c. If we want to evaluate the gradient of the curve at a particular point, you know f prime of x is the general gradient of the curve at every point, at any point on the curve. But if we want to know the gradient of f of x at a particular point s equals to c, then it is given by f prime of c. We just change back our x to c. Then that is given by f prime of c. So from figure 1 above, from our figure above, we have that the tangent to the curve at point s equals to c is this. And notice that this tangent is parallel to this secant line. They are parallel. That means they will have the same slope. Since they are parallel, their gradients will be the same because parallel lines have the same gradient. So from the conclusion of mean value theorem, we now have that from figure 1 above, we have that our f of b minus f of a over b minus a, which is the gradient of the secant line like we have gotten over here. So the gradient of the above straight line, which is this secant line, is given by this. It is equal to the gradient of this tangent line since they are parallel at point C. From figure 1 above, f of b minus f of a over b minus a equals to f prime of c. So these two gradients are equal according to mean value theorem. So let's see some examples to have a proper understanding of mean value theorem. So example, does the function f of x equals to x minus x cubed satisfy the hypothesis of mean value theorem in the closed interval minus 2, 0? In the closed interval minus 2, 0. So how do we know this? Now, if it does, find all numbers C that satisfy the conclusion of mean value theorem. So let's move into the solution. Now, f of x equals to x minus x cubed is a polynomial of degree 3. And it is defined for all values of x in the interval minus 2, 0. Yes, because for it to satisfy the hypothesis of mean value theorem, what are the two hypotheses? Mean value theorem says that f, the function we are considering, must be continuous in the closed interval. 2, it must be differentiable in the open interval. Those are the two conditions for mean value theorem. So if the function satisfies the two conditions or the hypothesis of mean value theorem, then the last condition, the last conclusion of mean value theorem will hold. But if the function does not satisfy these two conditions, then this conclusion can never hold. But now we want to see if the function given to us satisfy the hypothesis of mean value theorem. That is, we want to see if the function is continuous and if the function is differentiable. So the function f of x equals to x minus x cubed is continuous because it is a polynomial function, and all polynomial functions are continuous. If you should look at this function has no point of discontinuity. It has no point at which it will be discontinuous. For every values in the interval minus 2 to 0, when we put in the values from minus 2 to 0 into this function, it will always be continuous because it will always be defined. We will always get values for this function. By the time we put minus 2 in this function, we get a value for f for the function. If you put minus 1 in this function, you get a value for the function. If you put 0 in this function, you get a value for the function. So there is no point in this function at which when you put it in this function, you will not be able to get a value for it. There is no such point. So this function is continuous in the interval minus 2, 0. So we conclude that f of x equals to x minus x cubed is a polynomial of degree 3, and it is defined for all values of x in the interval minus 2, 0. Hence, we say f of x is continuous in the interval minus 2, 0. That is the first condition. It satisfies the first condition. So secondly, we want to know if that function is differentiable. How do we know if it is differentiable? What you have to do firstly is to differentiate the function. Differentiating this function using polynomial rule, we have that f prime of x equals to 1 minus 3x squared. This is the differentiation of this function, which we call f prime of x. So we now check if this function is defined in the open interval minus 2, 0. We consider the open interval. We are going to neglect minus 2 and 0. We consider the values between minus 2 and 0. What are the values between minus 2 and 0? We have minus 1.99 and so on up to minus 1.9999. So now we are going to consider the values between minus 2 and 0. And the values between minus 2 and 0 for this f prime of x, by the time you put any value between minus 2 and 0 into this function, this f prime of x also will always be defined. So f prime of x, which is 1 minus 3x squared, is also a polynomial of degree 2, which is also defined for all values of x in the open interval minus 2, 0. Because for every values of minus 2 to 0 in this open interval, for every values of x you put in this f prime of x, there will be no point at which this f prime of x will not be defined. It will always be defined for every values in this function. So hence we say that f of x is differentiable in the open interval minus 2, 0. So this we have check for the two conditions of mean value theorem. So the function satisfies MVT since the function is continuous in the closed interval and it is also differentiable in the open interval. So it satisfies MVT. So since it satisfies MVT, that means there is a point C in between A and B such that f of B minus f of A over B minus A equals to f prime of C. So we are asked to find that C now, because from the question it says if it does, find all numbers C that satisfy the conclusion of MVT. So now we move into finding the C. Now to find all C's that satisfy the mean value theorem, we need to compute f of A, f of B, and f prime of C, because from this formula we need f of A, f of B, we need f of A, we need f prime of C, but we already know our B and we already know our A, because this B and A is the interval. The B and A are representing the interval given to us. In this case, this is our A, which is -2, and our B is 0. So from the formula we need to compute f of B, f of A, and f prime of C. So now to find all C's that satisfy the mean value theorem, we compute f of A, f of B, and f of C. So let's compute that. Now from f of x equals to x minus s cubed, which is the question given to us initially, and this is the interval -2 and 0. So computing our f of A equals to f of -2, because A in this case is -2 and this is f of -2. Following the definition of the function, we are going to have that our f of -2 is what? Anywhere we see our x from the definition, we change it to -2. So f of -2 will now be -2 minus -2 raised to power 3. And evaluating this, you are going to have -2 minus -8, and this is -2 plus 8, which is C. Therefore, our f of -2 is 6. So we need to compute f of B also. So f of B in this case is f of 0, because our B is what? Is 0 here. So now f of B is f of 0. Following the definition, we have that f of x equals to 0 is equals to x minus s cubed. So following the definition, we have that f of B, which is f of 0, equals to 0 minus 0 cubed, because anywhere we see x from the definition, we change it to 0. So here we have 0 minus 0 cubed, which will give us 0. So therefore our f of B is what? Is 0, which is our f of B is 0. Now we need to find f prime of C. But before finding f prime of C, we need to get the f prime of x. How do we find f prime of x? Don't forget that f prime of x equals dy dx, that is differentiating that function with respect to x. By the time we differentiate this function over here, we are going to have 1 minus 3x squared. So f prime of x now is 1 minus 3x squared. Therefore, f prime of x equals to 1 minus 3x squared. So to get our f prime of C, from the definition of f prime of x to be 1 minus 3x squared, our f prime of C, we just have to change from the definition, we change x to C. Anywhere we see x here, we change it to C. So f prime of C now is 1 minus 3c squared, because this is x squared, then we change it to C to get our f prime of C. Our f prime of C now is equals 1 minus 3c squared. So by mean value theorem says that f of B minus f of A over B minus A equals to f prime of C. Our f of B, as we have gotten, our f of B is 0, which is 0 minus f of A. Our f of A is 6. So we have that f of B is 0 minus 6 over our B is 0 and our A is -2. So B minus A will be 0 minus -2, which is equal to f prime of C. F prime of C here is 1 minus 3c squared. So our f prime of C is 1 minus 3c squared. So now evaluating this, we have that this is 0 minus 6 over 0 minus -2 equals to 1 minus 3c squared, and this is -6 over 2, which is equal to 1 minus 3c squared. -6 over 2 is -3, which is equal to 1 minus 3c squared, And collecting like terms over here, we have minus 3 minus 1 equals to minus 3c squared. And minus 3 minus 1 is minus 4, which is equal to minus 3c squared. And making c squared the subject of formula, we have that c squared equals to minus 4 over minus 3, which is 4 over 3. So taking the square root to get our c, we have that c equals to plus or minus square root of 4 over 3, and which is equal to plus or minus 2 over root 3. Therefore, c equals to 2 over root 3, or c equals to minus 2 over root 3. Because of this plus or minus, because of the square root, we are going to have two answers. That is 2 plus 2 over root 3, or c equals to minus 2 over root 3. So now we can leave our answer as this. And we can as well rationalize our answer. Rationalizing, we have that c equals to 2 root 3 over 3, or c equals to minus 2 root 3 over 3. How do we rationalize? We multiply the numerator and the denominator. We multiply the numerator and the denominator by root 3. And also for this, multiply the numerator and the denominator by root 3. By doing that, we will have that our c equals to 2 root 3 over 3, or c equals to minus 2 root 3 over 3. So that is how to solve, or how to find the value of c according to the conclusion of mean values theorem. So here I have some practice questions for you to have a proper understanding of what we have been talking about on mean value theorem. So now, these are the questions. The first question says, does the function y equals to x squared over x plus 1 satisfy the mean value theorem in the closed interval minus 2 to 2? If it does, find the values of c's that satisfy the conclusion of mean value theorem. What you need to do for this first question is to check if this function has a point of discontinuity. Yes, this function has a point of discontinuity, and the point of discontinuity of this function is minus 1, because by the time you put minus 1 in this function will be undefined. We end up having 1 over 0, which is undefined. So the point of discontinuity of this function is minus 1. Then check if minus 1 is in the interval. In this interval, okay, I won't tell you if minus 1 is there or not, but confirm yourself. If you end up having minus 1 in this interval, that means this function is not continuous and it does not satisfy mean value theorem, since it is not continuous. And if minus 1 is not there, that means this function is continuous. Then you go ahead to check if it is differentiable and the rest. So now let's move to the second question. The second question says, determine which of the following functions f of x satisfies the condition of the mean value theorem, and find the values of c for which they satisfy the mean value theorem. The first function is f of x equals to x squared minus x cubed, and the closed interval given to us is minus 2 to 1. The second one is f of x equals to 3x cubed minus 9x squared minus 3x, and the closed interval is from minus 2 to 3. So with the aid of solving mean value theorem like we have done in the previous example, you can try to do these practice questions. And if you have any questions concerning this class or this question, you can please drop in the comment box below. And please subscribe to my YouTube channel, like and share the video, and don't forget to click on the notification bell. I will see you in my next video.